Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Apache Tomcat is one of the most widely used web application servers in the Java ecosystem. Originally developed by Sun Microsystems and later donated to the Apache Software Foundation, Tomcat serves as a reference implementation for Java Servlet and JSP technologies. Unlike full-fledged Java EE application servers, Tomcat focuses on being lightweight and efficient, making it ideal for developers who want to run Java-based web applications without the overhead of additional enterprise features. Tomcat has earned its reputation due to its simplicity and efficiency. It's particularly popular among startups and enterprises looking to build scalable web applications quickly. Being open source means no licensing fees, and its modular architecture makes it easy to customize and extend. With strong support from the Apache community, Tomcat is also a great fit for modern DevOps environments, especially when used alongside tools like Docker and Kubernetes. It's important to distinguish between Tomcat and full Java EE application servers like WebLogic or JBoss. While Tomcat only implements Servlet and JSP specifications, full application servers provide additional features such as Enterprise Java Beans, EJB, Java Message Service, JMS, and transaction management. For many modern applications, especially those using frameworks like Spring Boot, Tomcat's lightweight nature is actually a benefit rather than a limitation. Understanding Tomcat's architecture is crucial for mastering its capabilities. At the top level is the server, which represents the entire Tomcat instance. Each server contains one or more services which group together connectors and an engine. The engine is responsible for handling all requests for a given service, routing them to the appropriate host, which corresponds to a virtual host. Finally, each host contains multiple contexts, representing individual web applications. This hierarchical design ensures flexibility and scalability. Let's break down the core components in detail. The server is the top-level element that starts and stops the entire Tomcat instance. A service combines one or more connectors with a single engine. Connectors are responsible for receiving client requests and passing them to the engine, which routes the request to the correct host. Each host can contain multiple contexts, representing different web applications. This structure enables Tomcat to manage multiple domains and applications efficiently. The connector component plays a critical role in Tomcat's ability to receive and process client requests. It supports multiple protocols including HTTP/1.1, HTTPS, and AJP, which is commonly used when integrating with Apache HTTP Server. Each connector can be configured with thread pools, connection timeouts, and buffer sizes, allowing fine-grained control over performance. Understanding connectors is essential for optimizing throughput and handling high-traffic loads. The engine component is responsible for routing incoming requests to the appropriate host based on the domain name. Each host can host multiple web applications, represented as contexts. These contexts define how individual applications behave, including their session management, security constraints, and resource mappings. Valves and realms can be added at each level to provide custom logic for access control, logging, or monitoring. When you install Tomcat, you'll notice a well-organized directory structure that reflects its modular design. The bin folder contains startup and shutdown scripts. The conf directory holds all configuration files including server, XML, which defines the server's architecture, and web, XML, which sets default behavior for web applications. Web applications are deployed into the web apps folder, while logs are stored in the logs directory for troubleshooting and monitoring. Mastering Tomcat requires familiarity with its key configuration files. Server, XML is the heart of the configuration, defining services, connectors, engines, hosts, and contexts. Web, XML provides default settings for all web applications, such as welcome files and session timeouts. Context, XML allows per context configuration, while Tomcat users, XML controls user authentication and authorization. Properly configuring these files ensures secure and efficient operation. Deploying applications to Tomcat is straightforward. You can simply drop a WAR file into the web apps directory, and Tomcat will automatically unpack and deploy it. Alternatively, you can use the Manager application, a built-in web interface that allows you to upload WAR files and manage running applications. Each deployed application gets a context path that determines how users access it via the URL. Security in Tomcat revolves around realms, which connect to user databases or LDAP directories to authenticate users. Tomcat supports SSL/TLS encryption for secure communication, and its built-in manager and host manager applications are secured out of the box. For more advanced needs, custom valves can be implemented to add logging, IP filtering, or rate limiting to enhance security. Performance tuning is essential for running Tomcat in production. Start by optimizing JVM settings like heap size and garbage collection algorithms. Configure connector thread pools to match expected load, enable compression for faster delivery of static assets, and implement connection pooling for database interactions. These steps ensure that your Tomcat instance runs smoothly under heavy traffic. For high availability and scalability, Tomcat supports clustering and load balancing. Session replication ensures that user sessions are synchronized across cluster nodes, preventing data loss if one node fails. Load balancers like Apache HTTP Server or NGINX can distribute traffic among nodes, often using sticky sessions to maintain user affinity. Clustering is configured via cluster XML and requires careful planning to ensure consistency and performance. Monitoring Tomcat involves tracking access logs for client activity and Catalina logs for internal server events. Java Management Extensions, JMX, offer real-time insights into server performance and health. Additionally, integrating logging frameworks like Log4j or SLF4j helps centralize and manage application logs effectively. Proper monitoring is key to maintaining uptime and diagnosing issues quickly. Running Tomcat in Docker containers has become a standard practice in modern development. Official Docker images are available on Docker Hub, making it easy to spin up instances quickly. You can pass environment variables to customize configurations, and containerized deployments simplify scaling, versioning, and integration into CI/CD pipelines. This approach is especially beneficial for microservices architectures. Spring Boot revolutionized Java development by embedding Tomcat directly into applications. This eliminates the need for deploying WAR files to external servers. Instead, you can package your app as a jar file and run it with a single command. Embedded Tomcat is perfect for rapid prototyping, microservices, and cloud-native applications where simplicity and portability are priorities. While Tomcat is the most popular servlet container, alternatives like Jetty and Undertow offer unique advantages. Jetty is highly modular and excels in embedded scenarios, while Undertow provides excellent performance and is integrated into Wildfly. However, Tomcat remains the go-to choice for many due to its maturity, extensive documentation, and broad industry adoption. Tomcat releases are versioned in alignment with Java updates, ensuring compatibility with new language features. Some versions are designated as long-term support, LTS, meaning they receive security patches and bug fixes for extended periods. It's crucial to stay updated with supported versions to benefit from performance improvements and security enhancements, and to avoid unsupported software risks. Even experienced developers can fall into common traps with Tomcat. Leaving default passwords unchanged, disabling logging, or neglecting security updates can expose your server to vulnerabilities. Always enable HTTPS, rotate passwords, monitor logs, and apply patches promptly. Following best practices ensures a secure, performant, and maintainable deployment. Consider an e-commerce platform built on Java and Spring, hosted on Tomcat. To handle peak traffic, the platform uses a clustered Tomcat setup behind an NGINX load balancer. SSL certificates ensure secure transactions, while session replication keeps users logged in even if a node fails. This setup demonstrates how Tomcat can power enterprise-grade applications with high availability and scalability. Visualizing performance metrics helps you understand how changes affect your Tomcat instance. Optimized thread pools lead to higher throughput, while garbage collection causes temporary memory usage spikes. Implementing connection pooling reduces latency, and caching strategies can significantly improve response times. These insights guide tuning decisions for optimal performance. In cloud environments, Tomcat can be deployed on platforms like Oz, Azure, or Google Cloud. Auto-scaling groups allow dynamic scaling based on demand, while managed services like AWS Elastic Beanstalk reduce infrastructure management. Container orchestration tools like Kubernetes provide even greater flexibility, enabling you to manage clusters of Tomcat instances efficiently. Tomcat integrates seamlessly into modern DevOps workflows. Continuous integration and continuous deployment, CI/CD, pipelines automate application deployments, while monitoring tools provide real-time visibility into server health. Infrastructure as code ensures consistent environments, and automated testing guarantees that new releases meet quality standards before going live. Hardening Tomcat for production requires disabling unnecessary services and connectors to reduce attack surfaces. Restrict access to the manager app, enforce strong passwords, and implement role-based access controls. Always enable HTTPS and disable outdated or insecure cipher suites. These steps significantly improve the security posture of your Tomcat deployment. Troubleshooting Tomcat issues often starts with reviewing logs and understanding error messages. Class not found exception usually points to missing dependencies, while out-of-memory error indicates the need to adjust JVM heap size. Connection timeouts suggest tuning connector configurations, and session loss may require enabling session replication in clustered setups. Tomcat is a perfect fit for microservices architectures. Its lightweight footprint and support for REST-TFL APIs make it ideal for building and deploying small, independent services. When embedded in applications, Tomcat eliminates deployment complexity. Combined with orchestration tools like Kubernetes, it enables scalable and resilient microservice ecosystems. The Apache Tomcat community is vibrant and supportive. Official documentation, mailing lists, and forums provide valuable resources for learning and troubleshooting. GitHub hosts the source code and issue tracker, making it easy to contribute or report bugs. Numerous blogs, YouTube channels, and online courses offer in-depth tutorials for both beginners and advanced users. Looking ahead, Tomcat continues to evolve with the Java ecosystem. Future releases will focus on better cloud-native support, enhanced security mechanisms, and tighter integration with modern frameworks like Spring Boot and Quarkus. Staying updated with roadmap announcements ensures you're prepared for upcoming features and improvements. Apache Tomcat remains a cornerstone technology for Java web development. Its balance of simplicity and power makes it suitable for everything from small startups to large enterprises. With strong support for DevOps practices and cloud deployments, mastering Tomcat is a valuable skill in today's tech landscape. Start experimenting with configurations, explore clustering, and consider integrating it into your CI/CD pipelines. Apache Tomcat stands out as a reliable, versatile, and community-driven solution for deploying Java web applications. Whether you're learning servlet technologies or managing production systems, Tomcat offers the tools and flexibility you need. As Java evolves, so does Tomcat, ensuring it remains relevant in modern development environments. Thanks for watching this deep dive into Apache Tomcat. If you found this tutorial helpful, please give it a thumbs up, subscribe to our channel, and share it with your peers. Drop your questions or topics you'd like us to cover next in the comments below. Until next time, keep coding and stay curious. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.